In this question, three vectors are given which are non-zero such that no two of them are collinear, and this condition is given. Okay, and it's given as theta is the angle between B and C vector. We need to find the value of sine theta. So let's use this condition. We can write it as minus C vector cross A cross B is equal to 1 by 3 magnitude of B C A vector. Use the vector triple product formula, that is take the far element, that is C dot B A as it is minus C dot A B as it is. Now let's compare the A vector with this. Okay, now we'll get it as minus C dot B is equal to 1 by 3 magnitude of B magnitude of C. We can write it as minus of B magnitude C magnitude cos theta, because theta is the angle between vector B and C. So it becomes 1 by 3 B C. Just cancel the magnitudes on both the sides. Now from here cos theta becomes minus 1 by 3. So from the Pythagoras theorem, we can write sine theta as 2 root 2 by 3. So this is the required answer to this question. In this question, it is said that vector A and B are not perpendicular, and C and D vectors which satisfy this equation, and it's also given that A dot D is 0. We need to find the vector D in form of B and C vectors as it is given in the options. So let's use this condition first. As A dot D condition is given, so we can do this thing. Just multiply with A vector on both sides using vector operator, okay? I mean cross operator. Now we use vector triple product, that is A dot C into B minus A dot B into C is equal to A dot D into B minus A dot B into D. It is given that A dot D is 0, so this whole thing will become 0. Now we need to find the vector D in terms of B and C. Just multiply this A dot B, it becomes, and bring the negative sign on this side. A dot C by A dot B of B vector, and now this becomes plus A dot B by A dot B is nothing but 1. C vector is equal to D vector. So if you carefully see that, C option will be the correct answer to this question. This question, it is said that a unit vector which is orthogonal, which is nothing but perpendicular to this vector and is coplanar with these two vectors. If you remember, I've discussed a very important note, that is a vector is perpendicular to this vector, let this vector be A, and it is coplanar, which means lying in the same plane with these two vectors. Let one vector be B and one is C. So now we can write it as this unit vector sum R can be written as A cross B cross C, which is nothing but it holds vector triple product. So just use the formula over here, that is A dot C into B minus A dot B into C. So A dot C is nothing but just multiply these two vectors, that is 3 minus 2 1 plus 6 becomes 7 into B vector, that is 2i plus j plus k. And A dot B is 3 2s are 6 plus 2 8 plus 6 14 into C vector. Now this gives 7 2s are 14 minus 14 0. 7 plus 14, that is 21 j cap. 7 minus 14 minus 7 k cap. So now this is the vector r, but we need to find this unit vector, which is nothing but r vector upon its magnitude. It becomes 7, take 7 common, 3j minus k cap upon, it becomes 21 square plus 7 square 49. We can write it as 7 3j cap minus k cap upon 7 under root 10. 7 7 gets cancelled. So 3j minus k cap upon root 10 is the required unit vector to this question. In this question, magnitude of A and magnitude of B is given, and it is told that A dot B is 0, and we need to find the value of this whole thing. So it looks something complicated, but it's very easy. First, let us find up to here, okay? By using a simply vector triple product formula, which becomes A dot B into A minus A dot A into B. I'm just using this thing, okay? Now, A dot B is 0, so this whole thing becomes 0. A dot A, according to the property, it becomes magnitude of A square into B vector. Magnitude of A is given, that is 2, which becomes minus 4B vector. Now, if you multiply, now use these two vectors also, okay? It becomes A cross, A cross. This whole thing is nothing but minus 4B, right? So, again use the vector triple product formula, that is A dot minus 4B. Just write A as it is, minus A dot A, write minus 4B as it is. Again, this inside it is nothing but A dot B. Again, this whole thing becomes 0. Now we can write it as minus into minus plus 4. This is nothing but magnitude of A square, that is again 4, and B vector, which is nothing but 16B vector. We can do that by taking 16. B vector can be written as magnitude of B into B cap. Magnitude of B is given, that is 3. 16 3 is 48. B cap is the required answer to this question.